Okay, so yesterday we did a outcome that was called solving a system of equations with 3 variables. Okay, and the method that you did yesterday was called elimination, where you stacked them on top of each other and tried to eliminate a variable, right? And that all was the exact same idea as your grade 10 outcomes, except for it was just one more step. So today it's kind of similar to the grade 10, where you're solving a system of equations. You learned this in grade 10. You learned that you could eliminate, which is stack on top of each other and get rid of something. You learned this in grade 10, where you could substitute something that's equal, you could replace it. And graphing. Okay, all these methods, does that sound familiar from grade 10? Okay, before we start this outcome, I want to remind you of 2 things. Here's one reminder. What's the answer to this question? What's the answer to this math question? What would you answer there for me? Plus or minus 5. That's a reminder. Okay? And a second reminder. How do you graph this thing? This was like February. What kind of shape does it make? It starts with a P. Parabola. It makes that kind of shape. How do you move on a parabola? What was that movement pattern? Squaring. Think about squaring. If I move x by 1, what is 1 squared? 1. If I move x by 2, what is 2 squared? 4. Do you remember that? 1, 1, 2, 4. What's the next set of points? 3 moves, 9 moves, right? Okay? Got it? That all has to come back to your memory. Okay? Another thing with memory. This is grade 10, graphing. What shape is just an X? What shape does that make on a graph? What did you graph in grade 10? You only did one thing. You graphed a line. Do you remember this? Y equals mx plus b. Does that ring a bell? Okay. What does this tell me about the line, that number at the end? The y-intercept. What does m represent on a line? A slope. What kind of movement do you do when you slope something? You do a rise over a run. So recalling, this would go from -5 on the y-axis. I would go rise to run 1. Up to, okay, does that make sense as a staircase? Up to over 1, up to over 1. Okay, good. These are all things that you know from the past. How to graph a line from grade 10, how to graph a quadratic from the start of grade 11, okay, and the quadratic answers. Okay, so here we go. So y equals x squared and y equals x plus 2. This is a system of equations. And we got quadratics in here. We got linears in here. Okay, so substitution. Here's my idea. If y is equal to x squared, can I go in here and replace that y? Does that make sense? You can take any equivalent and make a replacement. Okay, so that's the substitution, done. Okay, but now what? How do I solve this with the tools that I have? As soon as I see an equation that involves x squareds in there and x's in there, what's my idea? 0. That's my idea always. X squareds and x's have to have a 0. Okay, x squared's my boss. Do you always remember I like my positive boss? So that's where I'm moving. Okay, what do you do when you have a 0? What kind of process do you start now? Does it factor? Okay, I would try simple trinomial stuff. That's where I'm going. Simple trinomial, so I'm going to do what? Multiplies to the 2. I have to multiply to -2, so there's only one set of multiples. 2 times 1. One of them will be negative. I got to create an add of -1. Multiplies to that, adds to that, check. So the solution here is 2 and the solution here is -1. But you're not done. Okay, so what I'm going to do now is if x was 2, what do you do when you know a variable? What did we say yesterday? As soon as you know one of the variables, you do a plug in. Okay, so go up to the top. Does it matter where you plug it in? No. So either one of these works. If x was 2, y would be, well, 2 squared. So y would be 4. So that's one of my answers. Okay, and I'm going to have another answer. If x was -1, so I could plug it into here or here, doesn't matter. If you say here -1 squared is +1, or if you put it into here, -1 plus 2 is +1. Okay? Okay, let's try elimination. Okay, when you eliminate, you have to think about things as like columns, right? So when we did that process yesterday, we were like x's were on top of each other, y's were on top of each other, z's were on top of each other. So I'm going to revamp this. I like this column where the y and y are on top of each other. This one had an x squared, okay? I'm going to put 0x squared for this one. Do you see what I'm doing? I'm just putting like a placeholder. There was just no x squareds in this one. Okay? If I think about the next column, it would be my x column. So technically that would have no x's in it. And that had a x. And if I move to my next column, it would be the digit, just the number. So this had no numbers, and that had a 2. So I just kind of rewrote the equation with placeholders because I wanted columns. X squared, x number. So now I've just reorganized them so that they're stacked, organized, right? Okay, you kind of only have one choice. What's the one thing you could eliminate? You only have one option. What's the thing to get rid of? You can get rid of the y value, the y variable. Okay, so the question is eliminating. Should I add or subtract the elimination? I'm going to subtract, so I'm going to do that. Y subtract y equals 0. If you had a 1x squared, subtract no x squareds, you still have an x squared. No x's, subtract 1x, is now a negative x. No numbers subtract 2 is negative 2. And you know what we are going to do? We're going to stop because the process, guess where we are? We got exactly to this spot. So I would just continue the same way now, right? From here on, I would do the same. So we're not going to do the rest because it's the exact same stuff. Okay? Do you see it? So from there on, it just would be the same. So there's my solutions. Okay, so substitution, replace, and then figure out your algebra. Elimination, make stacks of the same thing. Okay, graphing. Okay, so my first thing was x squared. So what do I know about it? There's no extra things going on, so it's going to start 0, 0. There's no extra numbers. How do I move? Because there's no extra numbers, I move normal. What's normal? 1, 1. 2, 4. 3, 9. Okay, now we're going to go y equals x plus 2. Okay, what are the things I know about this? Okay, x, that's a line. Just a line. And what do I know about this line? Plus 2. That's going to be the y-intercept of this line. The slope would be how many x's do you see, and you only see one x. So as a fraction, you're just going to do ones and ones. So think about your stairs. You're climbing 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, now what is the answer? The answer is going to be, where does this equal this? Where do they equal each other? So you're looking for, where are they intersecting? So what's the answer to this one? 2, 4 and negative 1, 1. Hey, did that match all the work we've done over here? Yeah, so see how I did the same answer, 3 different methods though. Okay, I have 2 examples and then we're done. Okay, we're not going to do all these methods. We're going to pick which method seems like it would be the best fit. So here we go. Oh. Ready? What do you want to do? I'm going to give you 3 options. Eliminate, substitute, or graph. Should you eliminate? Should you substitute, or should you graph? What would be your number 1 choice by just looking? I'm picking eliminating. Okay, that would be the best. FYI, you don't even know how to graph these things, so that's not even the option. Okay, eliminate. Ooh, I like this. I like that setup. Those y-squareds could disappear quite easily. So, how would I make them disappear with elimination? Should you add or subtract the lines together? The answer to that should be that you're going to add. Okay, 3x squared. See, they're nice and stacked, right? You got everything lined up. The y squared's gone. 27. Divide by 3, algebra. What are you writing in that box? You're writing plus or minus 3. Okay, what do you always do if you have one of the variables? As soon as you have a variable, you're doing a plug-in. Okay, does it matter where you plug in? Nope. Okay, I'll pick the top one. Okay, I am going to plug in for x squared. What can I replace x squared with? I can replace x squared with 9. Okay, you might have picked the other equation, and that's fine. We're going to get to the same. I replaced x squared with 9, and then minusing 9 is negative 4. Divide is 4. Therefore, y equals, what are we doing? Plus or minus 2. Okay, I know how to graph this because I do this in advanced math in grade 12 if you take that. You don't have to know this, but I'm just explaining why you're getting all these pluses and minuses. This is a hyperbole, which would look something like this. And the second shape is an ellipse, which would look like this. Okay, how many times do they intersect each other? 1, 2, 3, 4. So guess what this answer would be? x3, y2. x3, y, negative 2. Over here would be negative 3, 2. Do you see how I'm using all the combos of the pluses and minuses? That's what would happen, okay? You don't need to know that, but I'm just explaining why that was happening. Okay. With this outcome, I'm just going to give you a reminder. I want to see how to answer this. How would you answer this? Just our reminder. This is just a random reminder. X equals, can you square root 7 nicely? No. So this is what I would do. I would just leave it, root 7, because I just can't square root that like I did 9 or 4. Okay, do you remember that one? Okay, and this is the last question of the day. Okay, we could try eliminating, we could do substitution. I'm guessing no one would really even pick graphing if you had to. Okay, I think either one of these would work, but I'm going to pick the best, which would be substituting. Okay, but I'm going to do some work before I substitute. Why don't I move that over there? If I move that, it would go y equals 5x squared subtract 70. I'm also going to do the same thing to this equation. I may as well do like a simplification. Y equals x squared minus 6. Okay, you could do elimination. I said that could work, but we're going to pick substitution, which means if this is equal to y, I'm going to replace the y over here. Does that make sense to you? An equal thing can make a replacement. Okay, what kind of just math work would you do? You only have x squared. You just have one variable thing. So you don't do the 0, okay? You don't have x squareds and x's. So that's not the idea. You're just isolating. So I'm going to be putting that x squared over together with that one. At the same time, if you're okay, I'm going to move the 70 number over. Isolating moves, move to make x squared together, move to make the numbers together. Okay, do you like what I did? Everyone's okay with that? Divide by 4. X equals okay, what do you do as soon as you have one of the things solved for? Now you got to do a plug in. That's always the process. Get something, now plug in. Okay, go back to the top. I would pick one of these two lines, whatever looks maybe the easiest. I'll go to this. Figure out y. Y equals x squared subtract 6. So what could I do as a plug-in? I could plug in something for x squared. I'm going to go to right here. What is x squared worth? 16. So y equals 10. That's it. There's no plus or minus on that. Okay? If you are a visual connector, I'll show you why. This is a parabola. This is a parabola. So if I had two parabolas, where do they intersect? 410 and negative 410. Okay, but 10 does not have two options. Do you see how those intersections would work? You could have the option of the plus 410 or the option of the negative 410. Does that make sense visually with those parabolas and the symmetric sets like that?